My name is Pedram Navid. I am the head of data engineering here at Dagster Labs. And we'll be talking about how we can reclaim the modern data stack using all the great open source tooling we got along the way. So let's get started. I think before we can talk about how we're going to reclaim this thing, maybe it's helpful to sort of understand where it came from, right? What are the origins of the modern data stack? We'll start with, like all good history lessons, they start with looking up old tweets to find out where things started. And this is the oldest reference I could find to the modern data stack. Our friend Craig Van Spal from 2014, he's about to tell us why a modern data stack is relevant for, well, we'll click. Oh, actually, it turns out that that was a Google Plus link, so we won't know about what happened, but that's okay. We'll go to the next oldest sort of reference to the modern data stack I could find, and this is from Gonzalo, and he says, "Come build a modern data stack to transform how a company utilizes it to serve its customers." Sounds great. LinkedIn link, much more likely to be alive. Actually, well, that's a 404, so that's not great. We keep digging. We're not one to give up. Here's a post from Treasure Data in 2017, so we're getting closer, about a modern data stack. And actually, it's a link that does work, so we're getting somewhere. But when you click on the link, it's not clear that this is actually a modern data stack. You read the fine print, and this is actually a customer data platform. Not quite what we're thinking about when we think of a traditional modern data stack. So we keep digging, and in 2018, friend of the show, TJ Murphy, he posts a couple of things about a modern data stack, which I thought was interesting. You know, he talks about how there's opportunity to reinvent the modern data stack, which is amazing because it hadn't even been invented yet, and we're already reinventing it. So, really forward thinker, this TJ Murphy. Um, and you can see he also actually asked someone to write a book on building a modern data stack, which sounds interesting. So we click on that tweet to see who's replying to, and actually the tweet's been deleted. Presumably, this person is still working on that book. So, um, you know, we don't give up. We keep hunting. April 2018, we finally start to see someone talking about a modern data stack, and this is Mode, a company that kind of still exists, and they really believe in this modern data stack idea. And then we keep looking, and Kinetica is starting to post about it. Fivetran is starting to post about it. In October 2018, Fivetran posts again. December 2018, Fivetran posts again with a Series A funding announcement. So now we know a modern data stack, whatever it is a real thing. And then it just sort of explodes from there, and everyone's talking about it. And I think that culminates in Snowflake with their big modern data stack announcement in 2019. So I think somewhere in this time frame, 2018, 2019, the modern data stack was born. But what is it? I haven't really told you what it is. I think there's uh, a lot of ways to look at it. One way is to ask a vendor what a modern data stack is, and they will tell you modern data stack is a collection of things that includes us. And the other way to look at it is what is like the nature and character of these things. And I think we've sort of congregated around the definition of this composable piece of a data stack, right? Very much built on this like Unix philosophy of small things done really well that connect well with other things. The other piece of it is it's really centered around a cloud data warehouse. I think with the rise of Redshift initially and then BigQuery, Snowflake, we really saw that there's really this value in centering a data stack around a data warehouse. And the other really important piece is that these things are relatively easy to implement, and they plug together again relatively well. When we think of older data stack systems, they were usually these behemoths, these large enterprise applications that were hard to build, hard to maintain, and very, very expensive. The modern data stack is actually something that tends to work across a spectrum of companies, where smaller businesses, startups can actually have a data stack that includes a data warehouse, which was previously something only reserved for larger companies. But like all good things, I think we get excited about something, a flurry of activity happens, interest rates are low, people put lots of money into these things, and I think we enter a hype cycle, right? People almost as soon as it was born have declared the modern data stack dead, right? In 2022, 2023, it's just it's over. And I think what this is speaking to is this Gartner hype cycle that we've probably all seen, right? There's this innovation trigger, which is like the birth of the cloud data warehouse. There's this peak of inflated expectations, coupled with fundraising announcements and people being excited about potentials and not having to use Hadoop. But what ends up happening is like the promises of the data stack, maybe the marketing didn't quite live up to the hype, and we get into this trial of disillusionment. Everyone claims it's actually dead before it was even born. And what I'm going to argue is we're actually now entering the slope of enlightenment. We're going to get a lot of benefits from a lot of the things that were born over the last 5 years from this modern data stack. And I'm going to say maybe don't throw out the baby with the bathwater. We got a lot of really great tools, and maybe there's a potential here to do more than what was previously possible. In many ways, I think some people saw DBT, which is at the core of this modern data stack philosophy, their change to consumption-based pricing as the final nail in the coffin, as like, this is proof and pudding that like the data stack is modern data stack is dead. It's just a land grab, and everyone's doing consumption-based pricing. I'm going to argue that's probably not the case. And if we look back in time, things weren't better. All right. A lot of times we look at what we have today and we say, this is garbage. This is too much. It's overcomplicated. I'm gonna encourage you to think about a time before the modern data stack, and you're gonna see really awful logos that are poorly scaled. That was one of the characteristics of older data stacks, and they had things like Hadoop, which nobody wants to use ever. Have you tried setting up Hadoop? Impossible, right? You need a team of 50 engineers just to make sure it's not breaking. Everything was built on the JVM. Nothing worked well. Nothing was interoperable, and they were all extremely expensive. We had Mongo. Remember that? Like, I don't want to go back to this, and I don't think you do either, right? So, I think yes, the modern data stack has its problems, but I'm going to suggest that maybe it's not all bad, and we did get a lot of nice things out of it, and it's not maybe as horrible as some people may want you to think. And what I'm going to specifically talk about is like the open source data stack and how over the past few years we've seen such technological innovation in open source tooling and standards that we can really do a lot that was previously really, really difficult on fairly large sets of data. And this is a little architecture diagram from George Heiler, and he talks a little bit about how he sees, the open source data stack and kind of what it looks like. What I'll do is talk a little bit about, the key steps I see as part of this pipeline. It really starts, with ingestion, obviously, right? That's we got to get the data first before we can do anything with it. And then we got to store it, transform it, orchestrate it, and then activate it in some way and maybe visualize it. These are sort of the key parts of a data pipeline. And when we think about ingestion, I think here is where we have a wealth of options. I think the first option we tend to reach to, and probably one of the best options as much as possible, is just plain old Python, right? Nothing wrong with writing some plain Python to take data out of an API or to unzip a file and extract it, right? I think so often we've become accustomed to managed SaaS solutions to solve this problem that we've forgotten that we were able to solve these things without paying, $50,000 a year just to ingest some data from an API. There's also some free open source tools like Meltano, Alto, Airbyte. Um, they're good, but I would say they have some issues around um, compatibility. I would say in many ways they tend to be very heavyweight, right? I think Airbyte famously has like 11 to 50 different services in order to run it, so it can be a little bit heavyweight. Tools like DLT take a different approach, and they're like, you know what? We're going to leave the orchestration concerns to someone else, and we're going to make just a very good ingestion tool. And DLT is a great example of that. There's some smaller, lesser known tools that I think are really interesting. Steampipe and Sling, which we'll explore today. PG2 Parquet, which is really a Rust package to take data out of Postgres and put it into a Parquet file, and many, many, many others. So a wealth of options here that I think are very, very, very good to use. On the storage side, is our old friend Postgres been around for 1,000 years, and it's going to be here for another 1,000. Um, Nothing wrong with Postgres. Often it works. I mean, you probably don't want to do analytical queries on your transactional database in prod, but that doesn't mean you can't set up a separate Postgres instance that's for queries if your data is, not too big. There's ClickHouse and duckdb, which is probably a better option depending on your needs. And then you can use file storage formats like Parquet, like Arrow, like Delta Lake, and 100 others coming out every day, it feels like, right? On the transformation side, we have wonderful tools like dbt, which works really, really well. There's extensions to dbt like dbt duckdb. We have polars, which is pandas but fast. And then there's Arrow Data Fusion, and probably a handful of others, because if there's one thing I know is software engineers will do anything to not write SQL. On the orchestration side, there's Dagster, there's Prefect, there's Airflow, there's a handful of other incumbents coming in. I think we have a lot of options here as well. I will actually give you a little demo of dagster to show you how this all kind of fits in together. And even on the BI visualization side, here I would say probably the least strong set of tooling because BI is just famously hard to build. But tools like Superset or Preset, Evidence, Lightdash, Metabase, great tooling that gets us, I think, pretty far and are pretty wonderful tools as far as open source goes. Whew. I talk so much, but that's because I'm more excited about building the actual demo with you guys than I am about talking about things. So what I'm going to do is show you a demo of how all this stuff can kind of connect together using open source tools to get data from a variety of places, connect it all together, put it somewhere, and then we can explore and report on it as well. So just a quick overview. We've got some CSV files that are zipped at some URL in the cloud somewhere that we're going to download using Python. This data is, if you haven't caught the theme, related to birds. We've got some Postgres data. This is just a Postgres database that's open to the world for some reason. We're going to use Sling to ingest data from Postgres. And we have a Mastodon API to give you an example of hitting a REST API. I'm going to use SteamPipe to do that. All three tools are going to take that data, write it to a CSV, and import it into duckdb. That's going to be our storage layer. We're going to do some transformation using dbt. And then finally, we're going to do some reporting using evidence. And hopefully show you how all this stuff can fit together, work on, I would say, pretty large amounts of data, like the zip CSVs. I think they're not small. They're several gigabytes in size, and we can do really quick aggregations using duckdb on it. So let's get started. I will pull up a couple things. Let's find VS Code. There it is. And I'm going to do two things. I'm going to first start Dagster just so it's running in the background. And I will pull up Dagster as soon as I find my mouse. And we're going to do our old friend localhost 3000. And I can get this over here. So this is Dagster. And if you don't know, Dagster is a data orchestrator. It's a great way to connect all the various pieces of the puzzle, right? It's asset-based rather than task-based. So some orchestrators are very much focused on, do X and do Y. In Dagster, we flip it around and we say, I don't really care how you do something. I care more about what you're producing. And in this case, we can see the assets we are producing. The assets are, maybe it's a CSV file, maybe it's a file downloaded from the internet, it's a table in a database, the actual underlying thing we care about. So we've got some raw data. That's one group of data here. And you can kind of see the theme, the things I've talked about, right? We're going to get data out of the internet. And these are these little checklist files. We've got the toots coming from Mastodon, from SteamPipe. And we got some event data and ticket data coming from Postgres. And we're going to ingest that using Sling. And I click over on prepared. You can see how a lot of this data gets sent to duckdb over here. And then we use dbt to do some transforms on it. And at the very end, I'll pull up evidence and show you how we can connect to duckdb to do some reporting on top of that, right? That's sort of what this looks like. It's real fun. You can, select your favorite assets and just click materialize. This will launch a run where you can see the assets materializing, get that doc out of the way. And here we go. You can see they start to run. And then once they're complete, I'll come back into here and show you how an asset looks. So here we had 20,000 rows coming from this events table. We can click on it. We can see the run history. You can see the lineage. You can see the plot. I mean, it's been the same number of rows because it's a not changing table, but over time, presumably that would change and you would see that, right? So that's the asset view. We'll go back in here and show you a little bit of like, what does it feel like to actually write these code, right? I think there's two places to start. One is really the resources itself, and then the next is the assets. So real quick, the resource is that connection to the outside world. It's how Dagster knows what that thing is. And in our case, we have a few resources here. As an example, we've got our duckdb database, right? And we're writing to a local file here. You could do in memory if all you're doing is processing. You could use motherduck if you want something in the cloud. Very easy to swap these things over. And you can change this based on your environment. For example, for local dev, you might want to use in memory. And then for production, you might want to use a cloud product. And then we use Sling, which is our way of slinging data out of Postgres and into some other destination. In our case, we're taking data out of Postgres and putting it into duckdb. And really, this is all it takes to set that up. You don't need a managed SaaS product to do it. It's actually quite simple to do. And then we've got some DBT here as well as a resource, and that's going to reference our DBT project, which you can see here. We've got a few models like um, some Allbirds data, some daily tickets, some top birds by year. And what's nice is if you look at Allbirds here, that's an asset. If you go back to our Dagster UI, you'll see Allbirds as an asset. And what's really cool is Dagster can actually read and parse this data here and says that like, oh, okay, this is actually coming from these three different sources. And so if I pull up our friend Dagster, if I pull up our friend Dexter, there it is. We go to Allbirds. Where are you? There it is. You can see it's inferred that Allbirds reads data from these three assets, and you can actually see the same SQL right here, as well as all that metadata. So it's a nice way to connect everything together. So that's the resources. We sort of define our connection to the outside world. Up next, we've got assets, right? And in Dagster, it's quite simple to build an asset. Really, all you do is add this little asset decorator on top of your function. And in our case, I have this little helper function here that takes data from a zip file, extracts it, and saves it somewhere. And then all my asset does is it calls that, and then it outputs some metadata about that asset, right? So we've got this checklist 2020 asset here defined, and Dagster creates that as a reference in the UI. And we do that for a couple different checklists. We do that for the sites data, for the species data. And then once we have all that raw data, the next step, as you might recall, is to put that into duckdb. And so I've created a new asset that is dependent on those two upstream assets. So this is how I tell Dagster, these two things are connected. And then all I do is I create some temporary tables using duckdb. I create a final table, which is just a union of those temporary tables. I select the count to get the number of rows, and I output that as metadata. And this is a fairly large query that's running using DuckDB, but it completes in just a handful of seconds because that's just the power of these tools. And so I do that for everything, right? For species data, the sites data, I ingest all that into DuckDB, and then eventually I take data from Mastodon and I want to do the same thing. For Mastodon, I'm using a sub process just to run it. So in Dagster, it's pretty flexible. Here, I'm just running the Steam pipe application, which lets you query an API as if it were a table, right? So I'm querying that and I'm outputting it to its CSV. And here's the path of that CSV, which I will then write into DuckDB as well. And then finally, to get the data out of Postgres, it's actually quite simple in really like 5 lines. I've told Dagster that I want to use a sling asset, create a group, create a ticket, and take data from the tickets source and write it to the tickets raw table in DuckDB. And so in this many lines of code, I'm actually extracting data from a database in Postgres and writing it to my storage layer, which is DuckDB. But you could imagine changing this to, for example, a Snowflake, Databricks, depending on your use case, right? And the nice thing is you can do a full refresh if your table is small, like in my case. You can do incremental if you have a primary key, that type of thing. So a very flexible system here. And so that's really it. I'll go back to our browser and we can kind of see some things have happened, right? I finished running these tables and now Dagster has says, well, you've updated this upstream data and now these are stale. So what we can do is we can just select a few of these. If you want to just materialize those, we can select this and we click on run, and Dagster will now update only the data that really needs to be updated because some of it, hasn't changed, but others has. And so Dagster will run these uh, assets. You can see it runs pretty well. And once it's complete, we'll have finally our DBT model with the most up-to-date data on everything here. You can also see the logs here for every single asset. You can click on one to get the logs just for that asset as well. And you can see it's materializing that data as well. So that's pretty much done. What I'll do real quick is show you evidence.dev. I will just run it like that. And okay, it should be open. So I'll open my browser. And evidence.dev is a very nice markdown based notebook tool. So what you can do is connect to DuckDB using evidence. And if I'll show you some of the data, actually, I have it here under reports. I have a very simple page, index.md here. And Really, all I'm doing is writing Markdown. So I've got my little title. I talk a little bit about the thing. I can insert graphics. All that's fairly trivial. But once you start adding a SQL code block, you can start to query your duckdb instance directly from your notebook. And so I'm writing just a simple SQL here. That's a handful. I'm showing it as a data table, but you can do more complex aggregations. You can do bar charts. You can do values. You can do anything really, line charts, and so on and so forth. And so if I open up the browser, we can kind of, let's do a refresh here. There we go. You can see it's querying DuckDB straight out of my notebook. And here, for example, you can see all 333 records from Allbirds. If I went in back in here and I said, oh, I don't know, um, 2, right? I save that, and before I can even switch, it should have been updated with 2020 records. So a very nice way to explore data. You can see the bar charts here, the tables, um, line charts, really, really nice. And it's all connected and powered by DuckDB. So it's super, super fast.